chemical equilibria deals with reversible reactions. For example, nitrogen gas reacts with the hydrogen gas to form ammonium gas. When ammonium gas is heated to decompose to form hydrogen and nitrogen, such a reaction is said to be reversible. In a closed container, nitrogen will react with hydrogen to form ammonia. Ammonia will decompose to form hydrogen and nitrogen, until such a time when the rate of formation of ammonia from nitrogen and hydrogen is equal to the rate of decomposition of ammonia to form hydrogen and nitrogen. At equilibria, the concentration of nitrogen, hydrogen, and ammonia will remain constant despite the fact that the reaction is still taking place. Nitrogen is reacting with hydrogen to form ammonia, and ammonia is decomposing to form hydrogen and nitrogen. The equilibrium position is expressed by equilibrium constant Kc, where Kc is equal to the concentration of ammonia raised to power 2 over the concentration of nitrogen times the concentration of hydrogen raised to power 3. Generally, for a reversible reaction, A moles of A plus B moles of B is equal to C moles of C plus D moles of D. Kc is equal to concentration of C raised to power C times the concentration of D raised to power D over the concentration of A raised to power A times the concentration of B raised to power B. Then units of Kc are obtained by the principle of dimension. From the previous expression, concentration of ammonia is in moles per decimeter cubed squared over concentration of nitrogen, which is moles per decimeter cubed over concentration of hydrogen, which is moles per decimeter cubed raised to power 3. So this is to power 4. When you take it up, it becomes moles per decimeter cubed minus 4, which is moles to power negative 2 decimeter cubed to power 6. Example 1. Write Kc expression is and determine the units for the following reversible equation. Means the first one, Kc will be equal to NO2 into the concentration of NO into the concentration of O2 to power a half. Units will be equal to moles per decimeter cubed over moles per decimeter cubed over moles per decimeter cubed to power a half. This one will go, then you get mole to power negative a half decimeter to power 3 over 2. The second one, Kc is equal to concentration of Hi squared over concentration of H2 into concentration of I E2. This is equal to moles per decimeter cubed squared over moles per decimeter cubed into moles per decimeter cubed So when this one will cross with this and you have no units. Here Kc will be equal to concentration of iron by iron tetroxide into concentration of hydrogen to power 4 over concentration of iron to power 3 times concentration of steam to power 4. So this will be equal to moles per decimeter cubed into moles per decimeter cubed to power 4 over moles per decimeter cubed to power 3 into moles per decimeter cubed to power 4. So this one will go. So you will get mole to power -2 decimeter to power 6. Those will be the units. Implication of Kc: the higher the Kc, the higher the yield. For instance, nitrogen reacts with the hydrogen to form ammonia. Kc will be equal to concentration of ammonia raised to power 2 over concentration of nitrogen times the concentration of hydrogen raised to power 3. So the higher the Kc, the more ammonia produced in this reaction. Then application of Kc, to determine the concentration is at equilibrium. Determine the concentration is at equilibrium.
The Science Foundation College enamave ku Lwejjinja ng'oyingira kilomita emu. Somero lya Dene Boarding ery'abawala n'abalenzi. Ku O-level tusomesa arts ne sciences ate A-level tusomesa sciences zokka. Omwana mulete ku The Science Foundation College. Ffe tusinga okusomesa sciences. Okumanya ebisingawo kuba ku 0753 8 27 09. The Science Foundation College, based on sciences and based for sciences.
Example 1. Nitrogen reacts with the hydrogen according to the equation nitrogen plus hydrogen is equal to ammonia. 1 mole of nitrogen was reacted with 2 moles of hydrogen. At equilibrium, 0.2 moles of ammonia formed. Calculate Kc. What do? We write our equation once more. Plus 3 H2 forms 2NH3. Initially we have 1 mole, we have 2 mole, we have no ammonia. At equilibrium, they have told us 0.2 moles of ammonia formed. So if 0.2 moles of ammonia form, how many moles of nitrogen reacted? Moles of nitrogen reacted. We say that 1 mole of nitrogen forms 2 moles of ammonia, NH3. Therefore, 0.2 moles of ammonia will require 1 times 0.2 over 2, which is equal to 0.1. Therefore, moles of nitrogen remaining will be equal to 1, which was originally there, minus 0.1, which is equal to 0.9. So 0.9 moles of nitrogen remained. Again, we find the moles of hydrogen which reacted to find the moles of hydrogen which remained. Moles of hydrogen that reacted, we see that 2 moles of ammonia require 3 moles of hydrogen. 2 moles of ammonia to form 3 moles of hydrogen would have reacted. Therefore, 0.2 moles of ammonia will require 3 times 0.2 over 2, which is equal to 0.3. Therefore, moles of hydrogen remained will be equal to 2 minus 0.3, which is equal to 1.7. So 1.7 moles remain. Our Kc is equal to NH3 squared over N2 into H2 cubed, which will be equal to, we only use condition is at equilibria. At equilibrium, so we have 0.2 squared over 0.9 times 1.7 to the power 3, which is equal to 0.009 moles to power -2 decimeter to power 6. Example 2, nitrogen reacts with hydrogen according to the equation. Nitrogen plus hydrogen is equal to ammonia. 1 mole of nitrogen was reacted with 2 moles of hydrogen. At equilibrium, 1.4 moles of hydrogen remained. Calculate Kc. First, we have to find the moles of ammonia formed. Also how to find the moles of nitrogen remaining. Moles of hydrogen reacted will be equal to 2 minus 1.4, which is equal to 0.6 moles. Then moles of ammonia formed 3 moles of hydrogen form from this equation 2 moles of ammonia. Therefore, 0.6 moles of hydrogen formed 2 times 0.6 over 3, which is 0.3, which is equal to 0.4. So 0.4 moles of ammonia were formed. Then the moles of nitrogen which reacted, moles of nitrogen reacted. We see that from this equation, 3 moles of hydrogen react with 1 mole of nitrogen. Therefore, 0.6 moles of hydrogen react with 1 times 0.6 over 3, which is equal to 0.2 moles of nitrogen reacted. Then moles of nitrogen remains. Moles of nitrogen remained is equal to 1 minus 0.2, which is equal to 0.8. But Kc is equal to concentration of ammonia squared over concentration of nitrogen over concentration of hydrogen cubed, which will be equal to 0.4 squared over 0.8 times 1.4 cubed, which is equal to 0.009. This will be per mole squared, decimeter to power 6. Example 3, we are just rephrasing the equation. Nitrogen reacts with the hydrogen according to the equation nitrogen plus 3 moles of hydrogen is equal to 2 moles of ammonia. 1 mole of nitrogen was reacted with 2 moles of hydrogen. At equilibrium, 0.3 moles of nitrogen had reacted. Calculate Kc. Again, write our equation. Nitrogen 2 plus 3 hydrogen 2 gas will give you 2 moles of ammonia. Initially, we have 1, we have 2, we don't have. This is initial. At equilibrium, they have told us 0.3 moles of nitrogen had reacted. So 0.3 react from 1, you get 0.7 remaining at equilibrium. From the equation, 1 mole of nitrogen react with 3 moles of hydrogen. 0.3 moles of nitrogen react with 3 times 0.3 over 1, which is equal to 0.9. Therefore, moles of hydrogen at equilibrium will be equal to 2 minus 0.9, which will be equal to 1.1. So 1.1 moles of hydrogen remained. Then moles of ammonia formed. 1 mole of nitrogen, 1 mole of nitrogen formed 2 moles of ammonia. Therefore, 0.3 moles of nitrogen form 2 times 0.3, which is equal to 0.6 moles. So 0.6 moles of ammonia formed. Our Kc is equal to 0.6 squared over 0.7 times 1.1 cubed, which is equal to, our Kc is equal to the moles of ammonia formed squared over the moles of nitrogen over the moles of, times the moles of hydrogen cubed, which is equal to 0.386 moles per mole squared, decimeter to power 6.
Dr Bbosa Science, kwano kwa beti science, love ya Bbosa Science, truth na beta, truth na omega, truth na alpha science.
Example 4. Hydrogen reacts with iodine according to the equation hydrogen plus iodine is equal to hydrogen iodide. A mixture of 0.8 moles of hydrogen and 0.6 moles of iodine we are allowed to react in a sealed tube at 450 degrees Celsius. At equilibrium, 0.2 moles of iodine reacted. 1. Write the expression for equilibrium constant, Kc. Kc will be equal to the moles of Hi squared over moles of H2 into moles of I2. So there is no units because moles per decimeter squared over moles per decimeter times moles per decimeter will cancel. Calculate Kc. We have seen that hydrogen reacts with iodine to form 2Hi. Initially, we have 0.8. We also have 0.6. We don't have hydrogen iodide. At equilibrium, they have told us 0.2 moles of iodine have reacted, so we remain with 0.4. When 0.2 moles react, we remain with 0.4. But 1 mole reacts with 1 mole. When 0.2 moles of iodine react, 0.2 moles of hydrogen will react, remain with 0.6. When 1 mole reacts, 2 moles form. When 0.2 moles react, 0.4 moles form. Therefore, our Kc will be equal to 0.4 squared over 0.4 times 0.6, which will be equal to 0.4 over 0.6, which is equal to 4 over 6, which is equal to 2 over 3. Example 5, carbon monoxide reacts with steam according to the equation. Carbon monoxide plus steam, you get carbon dioxide plus hydrogen. 1. Write the expression for Kc. Kc is equal to concentration of carbon dioxide into concentration of hydrogen over concentration of carbon monoxide times the concentration of steam. Then 2 equal moles of carbon monoxide and steam were reacted in 1 liter vessel. When equilibrium was established, the vessel was found to contain 37% carbon dioxide. Calculate the value of Kc. So carbon monoxide plus steam, you get carbon dioxide gas plus hydrogen gas. Initially, we have 1 mole, we don't have. Suppose X moles react. X moles have reacted, remain with 1 minus X. Here you get 1 minus X. When X react, you get X and X. It implies that total moles will be equal to 1 minus X plus 1 minus X plus X plus X, which is equal to 2. It implies that concentration of carbon dioxide is equal to X and the X over 2 is equal to 26.7 over 100%, which is equal to 0.54. When this is 0.54, this is 0.54. 1 minus 0.54 becomes 0.46. Even this one becomes 0.46, and therefore our Kc will be equal to 0.54 into 0.54 over 0.46 into 0.46, which is equal to 1.4. Example 6. Phosphorus 5 chloride decomposes at high temperature as follows. When 40.2 grams of phosphorus 5 chloride was placed in a 5-liter vessel and heated, 4.2 grams of chlorine was formed at equilibrium. Calculate. First, we calculate the RFM of PCl5, which is equal to 31 plus 35.4 times 5, which is equal to 208. So initial moles of PCl5 will be equal to 40.2 over 208, which is equal to 0.193. Initial concentration of PCl5 is equal to 0.193 over the volume 4.5 liters and is equal to 0.043. Then moles of chlorine is equal to mass of chlorine, which is 4.2 over RFM of chlorine, which is 35.4 times 2, which is equal to 0.06. Then the concentration of chlorine at equilibrium is equal to 0.06 over 4.5, which is equal to 0.101. Then from our equation, PCl5 decomposes to give PCl3 plus Cl2. Initially, the concentration of phosphorus was 0.043. At equilibrium, the concentration of chlorine is 0.013. The concentration of chlorine is equal to the concentration of phosphorus 3 chloride, which is 0.013. When 1 mole form, 1 mole decompose. When 0.03 form, 0.033 decompose, you remain with 0.030 moles of phosphorus at equilibrium. The concentration of phosphorus 5 chloride at equilibrium is 0.030. The concentration of phosphorus 3 chloride is 0.013 at equilibrium. Therefore, our Kc is equal to PCl3 times Cl2 over PCl5, which is equal to 0.013 squared, because the moles of this is the same moles as this, over 0.003, which is equal to 0.056 moles per decimeter cubed.